When I was younger, I thought of myself as being pretty resilient. If I got injured, I would recover quickly. If I got sick, I would get better quickly, right? I was pretty resilient at some of these things. Well, as I get older, I find that I'm not quite as resilient as I used to be. And in our IT infrastructures, we need to build resiliency into the architecture so that we can minimize the effects of an incident and minimize downtime so that our resources and assets are available. And that's why we need to now jump in and take a look at resiliency in our architecture. So let's start off by talking about diversity and resiliency. Now, here's the point I want to get across is that diversity within our infrastructure design isn't always a good thing. And that's because it can introduce complexity. For example, if we had a desktop environment with Windows machines and Mac machines and Linux machines, and maybe we had some Android devices, well, that means that our support personnel have to be able to support all of these different operating systems, and that is complexity. If we only had Windows operating systems within our infrastructure, well, then they would only have to learn to support Windows. It would be much simpler. So the idea is diversity isn't always a good thing when it comes to our infrastructure design. And another example of this would be if we were to design a new application and it was a database driven application, and we settled on using Microsoft SQL, so that's our MS SQL. That's a SQL database, and it's the Microsoft version. And we were building our application, and we're using this, and it's working really well. And then we decide, you know what? We're going to add another type of database to this. We're going to run the MySQL database as well. And then you know what? On top of that, let's figure out we're going to run another type of database. We're actually going to shift some data to the cloud, and we're going to use Amazon's DynamoDB. So now we're going to start using all three of these different types of databases with our application. But why? This is really introducing complexity. Shouldn't we just stick with one of these databases if it meets our needs? Well, the answer is probably yes, we should stick with one as long as it's meeting our needs. There's no need to introduce complexity into our infrastructure design. So really it comes down to the old KISS. Keep it super simple. I like to keep it simple. It helps things to work better. It reduces the complexity. So when we do have events, there are three different ways that we respond to these events. Number one, manually. We manually respond to them, right? We pull up in a fire truck over here, we get out our hose, and we put out the fire. We take care of the problem manually. But isn't there a better way to do it? Well, sure there is. We can use automation. We talked about automation in our last video. We talked about SOAR in our last video, which was dealing with incident response in an automated fashion. That's an example of some automation there, our SOAR. And that was to automate the response to an event that happens. So the event triggers a response, and the SOAR system went out and ran through the playbooks that we had designed for it. So it went through and first it quarantined some software, then it isolated a computer, and then it sent out an alert in our example that we had in the last video. But it was an automated response to something. So hey, that's great. We're now going from manual to an automated response, which is going to happen much more timely and much faster, right? So we're going to get a quick response, and that is great. But is there another way that we could do this, maybe even better? Well, yes, there is, and it's called orchestration. And the idea behind orchestration is that an orchestration platform is able to see the entire environment and all the pieces that are in it, the different servers and the applications that are in it, and the network pieces that are in it, and all of these things working together within the environment. So when something happens, the orchestration platform can then respond to that event, looking at the entire environment and making decisions based on how the environment is reacting to basically its response and the events that are happening. So if a response is triggered and it goes out and it responds, and then something else happens in the network because of the response, Well, then we can have a second response that happens to take care of this. And the idea is the orchestration platform has some intelligence built into it, whereas the automation platform really doesn't. It just automatically responds when a certain event happens, and it follows like a playbook or a set of steps that we define. Within an orchestration platform, there's the intelligence that's able to look at the entire environment and make decisions based on what's going on in the environment to provide a better response. And that is the three different ways to respond to an event: manually, automation, and via orchestration. Now, building resiliency in our infrastructure requires that we take our resources that we have, our assets, and we distribute them. And that's because if we have all of our eggs in one basket, we have all of our assets here in a single basket, and something happens to that basket, well, then something happens to all of our assets, right? Absolutely. So the idea here is that we want to take our critical assets and resources, and we want to distribute them if we can. Now, that means distributing them between different systems, so we have systems there, maybe between different applications, and we also want to distribute them geographically. And that's because it builds resiliency into our assets and our resources. Because if we have some of our critical assets over here and some over here, and one of these servers goes offline, we don't lose all of our critical assets. We still have some over here. And then vice versa. If this is in one data center and that data center was to go offline, well, then we'd lose all of our assets, and that's not a good thing. But if we separate them geographically, well, then the odds of us losing both data centers, maybe on separate coasts of a country, are very low in likelihood. So the distribution of our resources is going to help us build resiliency within our infrastructure design. Now let's talk about redundancy and high availability. Now, the idea is here that we can build redundancy in our systems. We have basically like redundant systems, if you will. And if we have redundant systems, then that provides us with high availability. And these redundant systems could be lots of things. It could be redundant servers that we have, or redundant databases. It could be redundant power, because power is a critical resource. We could have redundant disks in our data storage, like in a RAID array, where we have several disks and the data is actually striped across these various disks so that if one of them is lost, we still have enough data here to recover it and not lose anything. We talked about redundant servers. Over here, if we had multiple servers, they could be working redundantly. So if they have the same information on each of them and we lose one, well, guess what? The other two can take over the workload. We need redundant internet connections and networking connections. That's why many organizations will have two firewalls that are here at the edge of the network, and each one has a separate internet connection. And then those kind of do what we call like a cross connect to our internal network, so that if we were to lose one internet connection here or one firewall here, that we would still be okay. We'd still have our internet connection and firewall there to provide us some security. And of course, as we talk about power, we need to talk about cooling as well, because cooling is definitely critical when it comes to electronic hardware like servers and networking equipment, because they generate lots of heat. Now, when we're talking about redundancy and availability, we measure this in nines. And what I mean by nines is a number of nines. So if we had 2 nines, it would be 99% available, which comes out to roughly about 3.65 days of downtime every year. So you might say, well, I was 99% available. My servers were. That's great. Well, that's still like 3.5 days of downtime. So what if we were 5 nines? This was our 2 nines. What if we had 5 nines? 99.99% uptime. Well, how much downtime does that equate to? 5.26 minutes a year. Now, that's pretty darn good. 5.26 minutes a year of downtime. That's not bad at all. Doing pretty darn good there. So that's 5 nines. What if we went all the way up to 9 nines? So that's 99.1, 2, 3, 4, 5, 6, and 7. That's a lot of nines. So 9 nines equates to about 31.5 milliseconds of downtime a year. So that's like a hiccup is all that is. It's only losing a couple of packets at this point. So again, when we're measuring availability, we generally do so in nines. Now let's talk about, as we're talking about high availability and things being available, let's talk about data replication. Now this is different from backups. This is not a backup solution. So let's take backups and cross it off because this is not backups. This is taking a node here and it's replicating its data to another node. Now this node could be a server, or it could be some type of storage device like a NAS or a SAN, but it's something with data on it, and it's going to replicate its data in near real time. So the idea here is we want to replicate as much data as we can across this connection as fast as we can. So we have a second copy somewhere else. Now these could be in the same building. So if we had two of them in the same building, we would have that, and that would provide us some redundancy, because if this server was lost, then we could direct our users to this server, and they could immediately access the data again. Because if we didn't have this replication, and we only had one server and it went offline, and we had to restore from backups, well, that could take hours to do that. So that means hours of downtime, which is not good. So data replication helps us to build resiliency and lower our downtime in the event of an incident or losing a server or a service or an application or something. But even better would be to replicate these across a geographical distance. Remember, we talked about resource distribution and that it was good that we replicated data, or we had our data in more than one place. Well, this is an example of that resource distribution, without a doubt. And if we could replicate across a geographical distance, then that would be even better, because that way, if we did lose a server over here in this data center, then the other data center that we replicate to is on the other end of the country, and most likely this data center being impacted by a natural disaster or something, it wouldn't affect the data center over here, and we'd have our data here ready to be used by our users. So we then point them over here to the other server, and they're able to jump right back in and get back to work, and this will reduce our downtime. So again, replication helps us to increase resiliency, and it does so via resource distribution. We're basically distributing our data between different systems here. And then lastly, I want to talk about clustering. Now, clustering is the idea of taking something like multiple servers. It's taking a resource and multiple instances of a resource. Like in this instance, I've got 3 servers here, and it's clustering them so that they all work together and provide the same services to our users. And that way, if we lose one of them, the other 2 can continue to take care of the workload. Now, the example I want to talk about here is using VMware's vSphere clustering. And VMware is a hypervisor. It's a virtualization platform. And if we had it installed on these 3 servers over here, they would work in a cluster. And a cluster does require something to manage connections and the resources on these servers. And here it's done through VMware vSphere. And the idea is, if we're using this cluster to run virtual machines, we have all these little VMs running on these servers. We have several on each of them. And the great thing is they're using the resources of the physical underlying machine, and that's what VMware is taking care of as a hypervisor. Now, if one of these servers was to go offline, let's say this one up here, it experienced a catastrophic event and it is no longer able to function. Well, what would happen is the vSphere cluster would actually migrate these virtual machines over to these other physical machines. It would move them over here, and then they would start up on these other servers. So the idea is we have multiple instances of a resource, and they work together as a cluster so that if one of those resources was to go offline, that the others would take over the workload. And that's the idea of clustering. Now, what benefits do we get from clustering? Well, of course, we get a reduced downtime and increased resiliency. And it doesn't have to be just with VMware and Hyper-V and virtualizations. We use it with databases as well. Database servers can do clustering. What else? Email servers can do clustering. And even other servers like web servers, they can all cluster as well. So there's lots of different services out there that you can cluster. And the idea is we gain reduced downtime and increased resiliency. So these are several different ways we can look at resiliency and how we can build it into our infrastructure designs. I hope this has been informative for you, and I'd like to thank you for viewing.